Assalamualaikum, Doctor. This is the progress report for 2 weeks on hardware developments and software development. I haven't revised this one yet. Okay, so the objective of the main target for these 2 weeks is to revise faulty PCB design that I have fabricated earlier, and also to obtain the analog measurements from Arduino in App Designer MATLAB. App Designer is a new version of GUI, so I have created the App Designer. The platform kind of stuff. I will show you later. So the first part is revising faulty PCB design. So I have finished for the first week from the day of our meeting, online meeting, until maybe 23rd August. I have I've been revising the PCB design. So this is the output. This is the flow of what I've been doing for those more than a week of designing circuit. So this is the first circuit, DAQ version 1.0. This is one that I have fabricated earlier, and as I have mentioned in the report previously in the previous weeks, I mentioned that the routing is wrong. There are many faulty in my design where I use routing within the component that causes the high impedance, and this high impedance causes the small current to flow through, so there is an internal short circuit within the components. So when I compared these findings with my design, I kind of it kind of hits me that it really is because of the routing, because I use routing everywhere within this component. I told you, I mentioned earlier in the report that there are short circuit in here, and in here, and if you can see here, I have zoom in that the routing is within the component, and this is the area where the short circuits happen. So it's so it makes sense why there are many problems with my design. So I've been revising the design of the PCB. So I have rerouted the traces to avoid any routing within the components. So I have before I talk about what I've done in the latest design, I will explain more on what are others faulty on my design. So besides routing within components, I also mix analog and digital circuits in the same area. So this is my IC, switching IC. This is the digital circuits, and this is the analog circuit. So it's in the same area. So this causes the signal integrity problem, and also causes EMI problem. There are lots of causes of EMI problem, but one of it is the mixed analog and digital circuits. And also in the first design, in this version, I mix the power supply connectors with the sine wave, with the ground, with the power supply for switching IC, because there are two different power supplies. This is 5 volts and this is 9 volts, plus and minus 9 volts. So this whole thing causes EMI problem. And also the routing is the traces there, the spaces between the traces are narrow, so this causes the crosstalks between signals carried in the traces. So what I've been doing I make it short that I rearranged the routing, I try not to route within the components. That's all for this. This is still 2 layer, but then I when I study again, the proper design for PCB is, if you want to avoid MC problem, we should use 4 layers PCB, because it will dedicate each layer for different traces. So this will avoid in my problem. So because this is not a simple one circuit PCB, this is because 8 circuits, 8 channels. So there are chances that there are many signals on the PCB. So I thought I can't use 2 layers anymore, and I should consider to design 4 layers PCB. And these layers can be dedicated for different traces. So the first layer I dedicate for analog signal. Second layer I dedicate for digital. Third layer is for ground, for power plane, for power traces, and the fourth layer is for the ground routing, ground traces. So this is what I did in the version 2.1. I did that, but I haven't separated yet the analog digital signals. Analog and digital circuits. This is still mixed, because it's kind of ongoing learning, that I learn something and then I imply it directly, and then I found a new information, but I discovered new knowledge, and then I do again the rerouting. So that's why there are many versions of my design. So this one I changed to 4 layers to dedicate each layer for different, as I mentioned, and I also changed the connector to separate the ground, to separate the power supply and the sine wave. So it has 3 connectors for power, ground, and for 5 volt voltage supply, and 9 volts, and also for the sine wave. And so this whole thing just to reduce the AMI problem, because when I do the PCB layer when I do the testing for the fabricated PCB, the DAQ version 1.0, there are the signals that I obtain from the oscilloscope when function generator is connected to the circuit is very severe. The MI problem causes the MI is shown in the signals, the noises. Yeah. So this whole new design is just to really reduce or eliminate those AMI causes. The causes of the AMI. So in this part, I have separated the analog and digital circuits. I put the digital circuits in the middle and the analog circuits in the left and the right. And this kind of improved the routing and so I thought. But then I found out that the layer ordering is wrong. At first this one I use first layer for analog signal traces, second layers for digital traces. Even though I dedicated second layer for digital circuit, but I still use this layer for analog, as you can see, for analog signal. So this is still not optimizing the dedicated layers for dedicated signal. So then I changed the layer ordering. And also because the first layers and the second layers is signals, and then the third layers is power plane, power traces, and the fourth is the ground. So when I restudied the proper layer ordering, it should be that the signals is on the top layer, and then the second is the ground layer, and then the third layer is the power, and then the fourth is another signal layer. So I changed the ordering. I changed only for the ground layers. I put it on the second layers, and then the signal layer for digital I put it on the fault layers. But this haven't really I haven't and then I found out that I still haven't really separated the analog circuits from digital circuits. They still share the same area, and this will, there's no improvement in here. So that, and also the spaces here are too big, so I kind of confine it and I reroute it. I placed it from. I placed it to close it together, to bring it together, to bring it close together, so that the size of the board is reduced, and this empty space can be. We can maximize the use of the board. Sorry. That's all I did for this for the changes for the 2.3 and 2.4. That's all I did, and then I studied again about the ground considerations that every designer should consider. So when I studied again, my PCB here still share the same ground plane, and this doesn't really improve much for my problem. So, and also I found that this still the analog circuits and the digital circuits still using the same area. So in here, the final version of my PCB design, I separated the analog circuits and digital circuits. I've separated in different area. So what I did is I just split ground. I split ground to split the ground for analog and ground for digital. So this is what I did, and in this version, so I put a H bridge, which act as a common ground. So this is the only thing that kind of makes these two circuits connected. There are websites that I refer to that I should do this to split the ground for analog and digital. So this is what I did here. I put the ground polygon in between of the digital circuits and analog circuits, and this is kind of improve the whole thing, because I have separated this analog circuit and digital circuits, and I have I created the power polygon for voltage supply connectors. Here 5 volts, here 9 volts, and here 5 volts. And I put the signal. I separated the sine wave connectors away from the digital, so that hopefully it's kind of reduce any problem, and signal integrity. The spaces of the traces also I have improved. I have put some distance, acceptable distance. I increased the width of the trace for power supply, because that's the one that carries the most currents. So, and also the ground, I also increased the width of the trace. What else? Basically, this is what I did for this one week, almost 2 weeks of revising this PCB. As you can see, this is the first version 1.0, and this is 2.5. But I'm still concerned. I know I'm still concerned about the cost of the PCB design, of the new version, because 4 layers cost more money, kind of double than the 2 layers PCB. So I'm concerned if there is a silly mistake that I foreseen. that is unforeseen, that I didn't realize. So I'm still kind of hoping that there is an expert opinion on my PCB design, because I really want to reduce the cost of the fabrications. I don't want to, order it many times and just for the silly mistakes. So, and also I have changed the connectors, the type of the connectors here. Sorry, I jumped from one point to another. So yeah, that's all I did for PCB design, and this is the final version, the final look of the PCB. Thank you, Doctor. That's all for about the hardware developments on PCB designs.